Hey guys, in this video we're going to talk about some concepts that we're going to review that will help you with chapter 1 in the textbook. Okay, so the things that we're going to talk about today in this video are combining like terms, distributive property, and FOIL. Okay, so let's go ahead and start talking about terms. Okay, so what is a term? So a term just consists of numbers and variables stuck together with multiplication. So what do I mean by that? Well, I mean that you can have something like this. 3 times x times y is a term. Just a number is also a term. Just a letter, like you could have x, that's a term. That's a variable, or you could have z or y. 2x squared yz is a term that's all stuck together with multiplication. And x to the third is also a term. Now, if I gave you something like this, 2x plus 3, how many terms are there? Well, there's one thing that's stuck together with multiplication, and then there's another thing, right? And the terms are separated by either a plus or a minus sign, okay? So with that being said, what are like terms? So like terms have the same variables, same exact variables, with the same exponents on those variables. So let's do some examples. Are the following like terms? Okay, so the first one is 3x squared and 2x. Are these like terms? Well, the answer to this is no. And the reason is because even though they have the same variable x, the 2 and the 1 over here on this x are different. All right, the exponents have to be the exact same, okay? And if you don't see an exponent, it's understood to be 1. All right, so let's look at the next one. What about 7xy and xy? Well, yes, these are like terms because they have the exact same variables. They have x and they have y attached. And the exponents on these variables are 1 in every case. We have 1, 1, 1, and 1. So yes, these are like terms. What about 4x squared y squared and 3x squared y? Are these like terms? Well, no, these are not like terms. The reason is because of this y squared and this y. This guy has an exponent of 1, where this one has an exponent of 2. Okay, so if this was an exponent of 2, they would be like terms, but since it's not, they aren't. Okay, and finally we have two numbers, -6 and 10. Yes, these are like terms because the variable that's attached is understood to be x, right? So we have -6, or it could be really anything, any variable you like. And anything to the 0 power is just 1. So this is -6 times 1, 10 times 1. Yes, so these are like terms that have the same exponent. All right. So now let's talk about combining like terms. When I say combining, I mean adding and subtracting. So if we have 2 apples and we add 2 more apples, how many apples do we have? Well, we have 4 apples, right? What about pairs? If we have 3 pairs and 5 pairs, we have 8 pairs, right? If we have 6 apples and 4 pears, what do I have? Well, I can't really say that I have any apples. I can say I have 6 apples and 4 pear, but I can't combine them unless I want to just say I have 10 pieces of fruit. But in terms of apples and pears, I can only say that I have 6 apples and 4 pears. And that's how combining like terms are. So the apples and the pears example, this represents like terms. You can think about apples as like x, and you can think about the pears as like x squared. So in the first example, we have 2x plus 2x equals 4x. Okay. The next one, we have 3y plus 5y equals 8y. Okay. So we have like terms in this case, but in this last line, 6 apples plus 4 pears, we don't have like terms, so we can't combine them by adding. All right, so let's go ahead and do some examples where we can combine like terms. So when it says simplify, we want to combine as many like terms as we can. And so what I'm going to do first is I'm going to underline my like terms in the same color. So I have negative 3x, and then I have a positive 8x. The variable is x, the exponent's 1, so those are like terms. Then I have x squared, but it doesn't have a like term partner. And then I have positive x to the third and minus 2x to the third. These are like terms because they have the same variable x, and they have the same exponent of 3. Now what I like to do is I like to start with the highest power, and I like to just rearrange so that my like terms are next to each other. So I'm going to put this positive x to the third minus 2x to the third in the front, followed by the positive x squared, then the minus 3x, and then the positive 8x. And at this point, we can combine them. So we have 1x to the third minus 2x to the third is going to be minus 1x to the third, or minus x to the third. This guy just carries down because he doesn't have anything to combine with. Negative 3 of something plus 8 of something is going to be positive 5 of something. All right. So that is my answer. That's as much as I can combine, because all 3 of these things in orange, blue, and green are unlike terms because they have different exponents. Okay? All right, let's go ahead and look at the next example. So let's go ahead and just underline my squareds first. Okay, and then we have a third power right here. And then we have some x's. And we have a constant number. Okay, so let's write these guys next to each other, these like terms. We have 5x squared, positive x squared. Maybe I should write the x to the third in front. That'd probably be better. And then what's next? I have minus 2x, positive x, and then at the back we have positive 1. So we can't combine x to the third with anything, but these guys, 5 of something plus 1 of something is just 6 of that something. Okay? That's 6x squared. Negative 2 of something plus 1 of something is negative 1 of something. And then this constant doesn't have a partner, so he can just go down like the x to the third did. Okay? And this is our final expression simplified. All right, let's do some more. So let's do my x squareds first. It looks like the highest power. So we have negative x squared, positive x squared, 6x, 2x, and then for our constants, we have positive 8 and a positive 1. So writing these next to each other, we get this. So if I have negative 1 of something plus 1 of something, that's just 0, right? This is just 0, so I'm not even going to write that. That just becomes 0. What about this? 6x and 2x makes 8x. And then positive 8 and positive 1 make a positive 9. And that's going to be our answer, fully simplified. Okay, the next concept that I want to review is the distributive property. So the distributive property is basically this right here. It says if there's a number on the outside that's being multiplied by 2 terms on the inside, you just distribute that term on the outside by multiplying and adding throughout. Okay, so a times b gives us ab, and then a times positive c gives us a positive ac. Okay. So let's go ahead and just do some examples like this to refresh your memory. So first one is simplify negative 2 times 3 minus x. Now I know this is multiplication because right here there is no sign. There's no plus or minus sign, so I know that I'm going to use the distributive property. So the distributive property says I need to multiply negative 2 times positive 3, And I also need to multiply negative 2 times a negative x. Okay. So this becomes negative 6, and then negative 2 times negative x becomes a positive 2x. And that's all I can do. I can't combine anymore because I have unlike terms. So that is my answer. Okay, let's do the next one. We have 3 times a negative x, and then we have a 3 times a positive 8. Okay, so let's do 3 times negative x, and then we have 3 times positive 8. Okay, and so this guy becomes negative 3x. This guy becomes a positive 24, and I can't simplify anymore, so this is my answer. All right, let's do some more examples. I have negative x times x squared, negative x times positive 1. So this becomes negative x times x squared, and then negative x times positive 1. So this becomes negative x to the third power. So remember, you can multiply different exponents, you just can't add or subtract different exponents, okay? Then over here, we have a negative x, and that is all I can do here. Okay, now we have 3 terms in the parentheses, but that's okay. We use the distributive property just like we do when there's 2 terms inside. So we do this guy, this guy, this guy. So we get negative 2 times x to the third for the first one. And we have negative 2 times a positive 3x for the second one. And a negative 2 times a positive 1 for the third one. Simplify this out. And we get negative 2x to the third, negative 6x, and then a negative 2. And that's going to be our answer. Okay. All right, let's see. Where could we use the distributive property for this next example? Well, remember, whenever you see parentheses and then there's a sign between a number or a variable and the parentheses, so if there's no sign there, then you can distribute. So let's go ahead and do that. So I'm going to carry everything else down as it is. This plus 7 can go down. But then I'm going to do positive 2 times x is a positive 2x. Positive 2 times negative 3 is a negative 6. And at this point, I can combine like terms, because these guys are like terms, and these guys are like terms. Okay, negative 8 plus 2 is going to give me negative 6x. And then negative 6 plus 7 is going to give me a positive 1. And that's my answer. Okay. All right, let's do some more practice with this. So I'm going to carry down everything that's not being distributed. So what's being distributed? It's not just positive 4, okay? This negative in front of it means that the negative, because it's in front of the 4, it belongs to it. So we're actually distributing negative 4, okay? So let's bring everything else that's not going to be changed by the distributive factory down below. So in orange, that's my distributive, and I'm going to carry this 3 down, and I'm going to carry this positive 3y down. Okay, now I can use the distributive property. So I have negative 4 times negative 8y gives me a positive 32y. Negative 4 times positive 1 is a negative 4. And from here, I can combine like terms because I have constants right here. And then I have y terms right here. Okay, so 32 plus 3 is 35y. All right, so this becomes 35y and then negative 1. And that's my answer. Okay, all right, so let's see. What am I distributing here? Well, there's no sign right here between this guy and the parentheses, right? This is a term, a whole term. So I am distributing this thing, this positive 2z squared, into this parenthesis that contains 2z and positive y. Okay, so the only thing that's going to come down is this 5z squared in the front. All right, so let's go ahead and distribute this positive 2z squared. So what do I have? I have positive 2z squared times 2z, okay? And then I also have a positive 2z squared times a positive y, okay? Now let's see what I can do here. Well, z squared and z make z to the 3, and 2 times 2 make 4, so this is positive 4z to the 3. And then 2z squared y, you can't do anything there. And that's all we can do. We can't combine anything else. We could if this guy had a y attached to it, but it doesn't, so we're done. We can't combine anything else here. So this is our answer. Okay, so the next thing we're going to review is FOIL. So FOIL is just a special case of the distributive property. And what it stands for is first, outer, inner, last. And that's the way that we typically multiply the terms. Okay, so I have an example right here. So we have two binomials, meaning that we have two sets of parentheses with two terms in each parenthesis. Okay, so we have two binomials. And when we multiply these, first is going to be a times c in red, and outer is going to be a times d in orange, inner is b times c in green, and last is b times d in blue. Okay, so that's the way that you multiply these guys. So we're going to do a bunch of examples with these. So let's go ahead and simplify this. So we have x plus 3 squared. Now anything squared means that you multiply it by itself twice. So this is the same thing as x plus 3 times x plus 3. Now I do FOIL. So first is going to be x times x. Okay. Outer is going to be x times positive 3. Inner is going to be positive 3 times positive x. And last is going to be positive 3 and positive 3. Okay, and now I can simplify this out. I get x squared. This is x squared. This is plus 3x. This is also plus 3x. And this is plus 9. From here, you can combine these guys because they're like terms. And my final answer is x squared plus 6x plus 9. Okay, let's do some more examples with this. So we're going to do FOIL. So we do first 2x times x is 2x squared. Outer, 2x times positive 4 is a positive 8x. Inner, negative 1 times x is a negative 1x. And last is negative 1 times positive 4, that's a negative 4. Okay. Now I can combine these two, and I end up getting 2x squared plus 7x minus 4. And that is my answer. Okay, let's do the next example. First, we have x times x is x squared. Outer, we have x times negative 6, that's a negative 6x. Inner, negative 8 times x is a negative 8x. And last, we have negative 8 times negative 6 is a positive 48. All right, so we have x squared minus 14x plus 48. And that is our answer. All right, let's do one more. Okay, so now we have negative x times 3x, which is negative 3x squared. Outer, we have positive 2 times negative 5. That's negative 10. Inner, we have positive 2 times 3x is a positive 6x. First, outer. Oh, I think I did last first. I'm sorry, you guys. I messed up here. I mean, it doesn't matter if you do last, but anyway, let's just start over here. Let's start over. Okay, so first we got that negative x times 3x. Outer, we have negative x times negative 5. That's going to be a positive 5x. Inner, we have positive 2 times 3x is a positive 6x. And last is going to be positive 2 times negative 5 gives us negative 10. Combine our like terms, and we get negative 3x squared plus 11x minus 10. Alright guys, I hope this was helpful for y'all to review, and I'll see you guys next time. Thanks for watching.